Hi everybody, today we're going to talk about graphing. We're not going to spend a lot of time on here, but for tables and graphs you should be able to do this. This applies to tables as well. Again, this is all stuff you've seen before. This is absolutely nothing new. So you should be able to look at a table and plot data from it, and you should be able to notice trends based upon either the graph or the table. All right, and frankly I don't care which one I give you, a table or a graph, you should be able to do this. All right, so let's say that I give you a table. Right? And I tell you for a certain number of hours, then you'll go a certain number of miles. All right. So over here, this is the thing that you have control over, which means this is independent, and this is the thing that is going to be changing. So if I go 1 hour, I'm going to go 30 miles. All right. So that tells me that over here, this is your independent variable, and over here on the right, this is your dependent variable. All right. Now, what do you notice about the data? Well, I notice that my time, excluding this last one, which is kind of strange, but I go 1, 2, 3, 4. All right, and I notice that my distance is going 30, 60, 90, 120. Well, what do I notice about my time? My time as I go up is going up by 1 hour every time, and my distance is going up by 30 every time. So I should notice that, because that tells me this is something called a linear relationship. It's a direct relationship. As my time goes up, my distance goes up, and it's going up in a particular amount. Now notice I do have this thing over here where I have 6, so I've gone from 4 to 6, so I've essentially gone up by 2. So over here I would expect, instead of going up by 30, I've gone up by 60, and in fact that is correct, I have gone up by 60. All right. So our next step would be to plot the graph. Well, if I actually take this data and plot it, you will notice that I do essentially have, and I can't draw a straight line with this thing, but I will do my best. Right? There's a line, and that actually is a straight line. And you'll notice, by the way, it does come down here and intersects with 0, because if you start at 0, you haven't gone anywhere. Yeah, that kind of makes sense. All right? So you should be able to, from the data, plot the graph. All right? And you should notice it's a straight line. Right? And you have your independent variable, the thing that you have control over, that's down here. This is your independent variable. And up here, this is your dependent variable. You know, I have to learn how to use this thing better. Let's try that again. That's your dependent variable. The shape of the graph is a line. And the question is, can we interpolate? Well, interpolation simply means I want to look at 5 hours. I was never given the information for 5 hours. I was only given the information from 1, 2, 3, 4, and 6. Now I can go back, and I can look at my data, and I could say, well, what would be in the middle here if I had 5? And I could say, well, it would be the number right in between these two, right, which would be 150. So I should be able to figure that out looking at the table. I should also be able to figure that out looking at the graph. Well, you'll notice that over here I'm missing that number, all right? But if I go and I take this and I go down to my number 5, right? I come over here, and as I look over here, I go to my number 150. Okay? So here my graph is complete, and you'll notice that right about there is where we're talking about if I've traveled for 5 hours, I've gone about 150 miles. All right? Now that's called interpolation because I'm between 2 points that I'm given, which are these 2 points. But what happens if I want to continue this graph up this way? All right? Well, I should be able to extrapolate, in other words, go one extra piece of information further, which in our case, well, I know how long it takes me for 6 hours, which is 180. Since I'm going about 30 miles an hour, I should be able to figure out that my next one's going to be about 210, and I should be able to extrapolate my graph or my table to get up to that point. All right? What happens if I travel 16 hours? How far would I go? Or what happens if I said, well, I want 120 miles? How long would it take me? Well, you can do it 2 ways. You can draw this graph and just continue going way out there. All right? You can say that, well, I know I'm going 30 miles in 1 hour. Right? So I could simply multiply 30 by 16 to come up with 480 miles. Right? Since I go 30 miles an hour, I could divide 1,200 by 30 and come up with 40 hours. All right? For how long it would take me, right? The other way to do it would be to use my math skills, right? And my math skills tell me that I should be able to come up with an equation for a line. Now I could do that with a point slope formula. I could do that with y equals mx plus b. All right, and what's b? Well, b is my y-intercept. Where am I going to intercept? 0. So that number is going to be 0. And what's the slope of my line? Well, for every hour, I go 30 miles. For every hour, I go 30 miles. For every hour, I go 30 miles. So my rise over my run, my change in y, my delta y over delta x is going to be 30 for every 1 hour. So my m, or my slope, is going to be 30. Okay, you said, when would I ever use my math skills? These are your math skills, and folks, you need to be able to use them. You need to be able to take the math stuff that you learn in algebra, and you need to be able to apply it, or geometry, be able to apply it to chemistry. All right, because we're going to be working with lines and graphs and tables. Okay, so could you create an equation for this line? Sure, you could. The equation is y is equal to my slope times x plus b. Well, b is 0, so I don't have to do anything. So y equals 30x. So whatever my independent variable is, I multiply that, which is my hours, by 30, and I come up with my dependent variable, which is my distance in miles. So you should be able to do that. All right, here's a very busy graph. It's a chemistry graph, all right? But we should be able to get certain information out of this graph, and it's just looking at a graph and interpreting what it says. Down here on the bottom, right, we have temperature. Happens to be in degrees Celsius. Do you care? No. Right? Can you read a graph? You should be able to read a graph. You've been doing this since 3rd or 4th grade, right? And it's just the terms are different, right? And over here on our y-axis, all right, we have grams of solute in 100 grams of water. All right, so which one is dependent, which one's independent variable? Pause the video, figure it out. Okay, down here on our x-axis, we have our independent variable. Our independent variable is always down here, and our dependent variable is always y. All right, so you should be able to do that. Logical reasoning should tell you, let's look at this. Look at KNO3. Well, where's our KNO3 line? Well, that's this line right here. All right, that's this line. All right, and the KNO3 line says, look at the KNO3 line. What happens at 50 degrees Celsius? Well, here's 50 degrees Celsius down here, and if we come up to 50 degrees Celsius and we look at our KNO3 line, we see it crosses right about there. Okay, so that tells me, based upon this graph, that 80 grams of KNO3 should dissolve in 100 grams of water at 50 degrees Celsius. Now, if I change my temperature to 60 degrees Celsius, I would go and dissolve 100 grams. If I changed it to, where am I, 70 degrees Celsius, I would dissolve 130 grams. Right? So the change in temperature affects this graph. Right? What happens if I have twice as much water? Well, let's go back to this 50 degrees Celsius thing. At 50 degrees Celsius, I dissolve 80 grams of water. 80 grams of KNO3 in 100 grams of water. Well, if I have twice as much water, then I would dissolve twice as much stuff, or 160 grams. If I had 3 times as much water, I dissolve 3 times as much, or 240 grams. If I had half the amount of water, I'd only dissolve 40 grams. Guys, this is simply reading a graph, all right, and interpreting what's on a graph. The fact that it's chemistry doesn't matter. You've been reading graphs since you were 10 years old, all right, and you should be able to continue reading graphs and continue reading tables and make equations for lines out of tables so long as the lines are linear, all right, they're straight lines. All right, so what should you be able to do? You should be able to create a graph from data in a table. You should be able to identify independent and dependent variables. You should be able to interpolate data, finding data in between 2 data points. You should be able to extrapolate data, finding data that is further on down the line. And you should be able to interpret the data in the graph and develop conclusions based upon that interpretation. That's the hardest thing. All right? Now, folks, this is stuff you've been doing for years, right? I'm just asking you to apply it and remember it from your math skills, okay? You have a worksheet to work on. Go ahead and work on that worksheet, and then come back to class and you can take your test, okay? We'll see you in class.